go. Alright, my inclination is 19.7, his inclination is 19.3. That's pretty close. We can work with that. We'll want to correct that a little more later, but that's pretty good. So you can see the two hula hoops were pretty close. That's not bad. Alright, the next thing we want to do is, remember, we're orbiting the planet slightly slower than he is. We want to up that a little bit. We want to make our period even bigger than his. We want him to catch up. So how do we do that? Well, here's the lowest point of our orbit, and here's the highest point of our orbit. So so right now it's not that bad. So what I'm going to do is I'm going to burn in the prograde direction, and I'm going to raise this just a little bit more. Not a huge amount. There you go. So our orbital time is about is that right? Only 20 seconds? Well, watch what happens. I'm going to speed up time here, and you're going to see he's catching up to me. Because over here I can see the relative distance between the two spacecrafts, and it's counting down. Right now, he's about 80 kilometers away, but he's catching up. If we actually go to this view, if I look behind me, let's go in the prograde direction. If I look behind me, yep, don't see him yet, but I'll see him soon at this rate. I forget when the game makes it so he's visible. I think it's 20 clicks, but it doesn't really matter. Point is, it's going in the right direction. So this is a little bit of practice. You want to be more careful or less careful depending on how good you are at this. But at some point you want to circularize your orbit when he gets close enough. So you can see we're approaching a node right now. So let's fix that last little bit of inclination problem we've got. So I'm going to burn in the normal plus direction. And there's not much inclination difference. So I'm just going to burn really slowly until these two numbers match. That's pretty close. And you see that? We're basically in exactly the same plane at this point. And then the next thing I want to do is I want him to catch up. So we're going to let this go a little longer. You're going to see he's going to get close. 40 clicks, 30 clicks. And the next time we come around, when I cross into his orbit again, we're going to be really close to each other. Actually, yeah, no, this is alright. Let's keep going. He's going to be a little bit in front of me, but the orbits are set up right now so that I'm inside of him on half the orbit and I'm outside of him on half the orbit. So we're going to catch up right here. You can see we're only 9 clicks away from each other. If I go out here and I look in front of me, he should be out there somewhere. Oh yeah, I forgot. I don't have the little red markers. I've got to figure out how to fix that. I should see him out here. But when I get within 2K, I'll definitely see him because the physics engine will load him. And it doesn't really matter because I've got my computer telling me where he is. So at this point, you can see I have a relative velocity of him at 20, and I'm still closing on him. So I'm not going to do anything. I'm going to just let this happen. Now, in version 0.18, you're going to have a little marker that's equivalent to this button right here, which is relative velocity. If I want the relative velocity to increase, I'd push this, and it's going to point in the direction to increase the relative velocity between my spacecraft and his spacecraft. If I push this button, it's pointing along the vector that's my velocity vector minus his velocity vector inverted, and this will slow my spacecraft down relative to this will, relative to his position, slow down my spacecraft. The other one would speed it up. So we can use these instead of the nav ball indicators to do the same thing. So we're gonna let things continue as they are. There's no reason to stop them while this number continues to count down. As soon as it starts slowing down and then stopping and then inverting, we're going to burn to make our relative velocity 0. That's going to also tend to make our orbit look more like his orbit, which makes a lot of sense. I'm burning to make this smaller, and by the same token, that means that I'm making my orbit look more like his. Alright, so might as well speed this up a little while we wait. And I'm sorry, if you're playing this game, I must have a setting messed up, but when you're playing this game, you'll probably see this guy with a little icon that says he's over here. I probably need to change the graphic setting. Okay, see that? Relative velocity is now climbing back up. That was our point of closest approach. So now I'm going to burn and make this number basically 0. Alright, so if we go over here, things are not aligned yet because I'm below him, but our relative velocities right now are identical. So the next thing I can do is I can thrust towards him. Now there will be an indicator on the nav ball in 0.18 which tells you to point in his direction. The point in his direction. I'm going to use smartass to do the same thing. So I'm going to point in his direction. I'm going to increase my velocity relative to him. So I'm now closing on him. Now, I'll only close on him for a little while because I've thrusted in such a direction that I'm changing my orbit. So you can see I've moved my orbit out towards his, and we're going to try to intersect, or out here at some point. But these orbits are not identical, so after some time I'll start drifting apart. But we're close together now, so I can start doing these little burns like this. And what you'll see, what'll happen is I'll close on him for some point, I'll hit a closest point of approach, and then I will start drifting away from him again. Let's up that even a little more. Because we're really close together, we're within 5 clicks of each other, these small little changes will gradually circularize my orbit, or circularize is the wrong word, will match our orbits. And that's what we want. In order to dock, we want to get within sort of a click from each other with very closely matched orbits. That will naturally happen as I make these small adjustments that I'm showing you here. Alright, so we're going to speed up time again a little bit to get these two things to... I'm going to wait for my closest point of approach, and then I'm going to cancel this velocity out again. This looks like it's going to happen somewhere around maybe 3K, maybe 2.5K, something like that. Yeah, this is a good burn. We're getting close. Remember, the physics engine will start rendering him at 2K, so I won't need that stupid little red icon on anymore. Alright, getting close to the CPA there. So I'm going to cancel this velocity. And let's see what our orbits look like. They're going to look like they're matching a lot closer than the last burn, because we're much closer to his actual. Look at that. Almost identical. So let's do this one more time, and we should basically be in dock range once we do that. So I'm going to point back at him. You can see I'm using very little fuel to do this. It does not take much. There he is, right there. You see that? You see that little speck out there in the distance? That's the physics engineering now rendering him. So I'm going to make one more burn. Now you may remember some of the videos by the dev team who were showing you this, I think on the last chat. And one thing I noticed with them is they were being, again, really conservative with their burns, really slow. There's no reason you need to